Hello.
Oh, hey, Emily. I think you're muted.
We're just about to start.
Okay, good.
So, yeah, I think Monica will introduce us a little bit, and then you're up on the screen so people can hear and see you.
Sounds great. Yep.
And do you want to share the screen or the slides from your end?
Yes. Probably from my end, so I can have control on the progression of the slide. Okay. Yeah, let me share my real quick.
There's a lot.
Okay. You're currently muted right now, so.
Can you hear me, Dr. Zhao?
Yes.
All right, wonderful.
All right.
So we're gonna wait for a minute. Of course, we have 11 seconds before the class starts.
Oh, no problem at all. You're very precise. Can you see that my screen from your end?
I don't know who is sharing screens. Yeah. We are sharing screen, or he is?
Yeah. We can see your screen, yeah.
Okay. Then you want to make it big?
Right. I'll make it big once we start the presentation.
Yeah, I gotcha. All right. There are a lot of classes finishing just before ours, so people are late. But we're gonna kick it off because we want to start on time. All right.
Sounds great.
So,
yep.
So today, what we're gonna do is to talk about projects, and we have a number of pitches from people who have been thinking about these projects. Some of it is, for example, from experts like Dr. Zhao. Some of these talks are given by students in the class. And after the pitches, I want to give you a little bit of guidelines or help with designing your project, okay? And we will talk about that after we finish with the individual projects. And we are soliciting feedback from everybody in the class. So if you go to the webpage, to the main class webpage, on the very top, there is a link to a Google Doc. We want it to be in real time. You listen to the projects. Everybody has to write down what you think about every single project. It's going to be short, just to say a little bit like what you like about the project and some suggestions. So this is how we can, given that we have such a large class, we want everybody to participate. And we also want to take advantage of that and get feedback from tons and tons of people. All right? So please open your web page right now and get set up. And it is also a very easy way for us to figure out who is coming to class. And as you know, that class participation is mandatory for people other than those who are taking it as CPD. Okay? So with this, let me kick this off. And today, the first speaker is Dr. Zhao from the Mayo Clinic, and he has an exciting project to share with you. All right, please take it away, Dr. Zhao.
All right. Well, thank you, Professor Lam. Just want to make sure that everyone can see our slides from here. Is it good? Sorry, I can't hear anyone. Hello?
You're all good.
All good. Sounds great. Yeah. All right. Well, so thank you everyone for coming to the class. And then we're trying to pitch a collaborative project that is called Cardio Agent, which is going to be an AI-based mini cardiologist to enhance the patient care in the cardiology field. So I'm an assistant professor of medicine at the Mayo Clinic, and then I have been at Stanford for the past 2 years, and we're running collaborative projects between cardiovascular medicine and on the AI field. We're trying to explore this healthcare and AI revolution, and then I believe this will be a very exciting project that to inspire people in this classroom. All right, so why do we need a cardio agent? So the rationale is that we need an always available cardiologist. So as clinicians or cardiologists or clinicians, we're busy. And then there are more questions or more patients to serve than we can really handle. So that actually comes with the increased burden of the cardiovascular disease, which happens in the past 10 years. People are getting older, the population getting more aged. And then that actually comes to a longer waiting time, and then also heavier workloads for cardiologists. And then over time, with the technology advancements, there are more and more knowledge gap between our specialty and then other providers. And that becomes a little bit difficult for us to really communicate with other specialty doctors or providers. And then that takes a longer time to communicate, and then for the team is to really reach a final decision making. And then this actually compromises the patient care quality and actually can make more patients dying from cardiac conditions, which they shouldn't be. And then this condition is even worse for hospitals in rural areas. So imagine that you're a doctor, internal medicine doctor, who cares of patients in a rural area, and then midnight your patient had a chest pain, and then you don't have access to any cardiologist around you. And the only access you could have is to call out to get a cardiologist's opinion, who is probably 100 miles away. And then at this time, you probably want to have someone like an AI assistant that can help you to sort out the first few steps, and then to think, okay, is there any workup I have to complete before I send this patient out? Or should I even call a cardiologist to wake someone up in the night? And then, yeah, so this is going to be helpful for doctors, especially they don't have direct access to specialists. And then so we can help them with our AI system to sort out what to do instead of stucking with your patient and like, I don't know what to do, like this one over here. And so our cardio agent system is designed to have to be a self-improving agentic framework. So the goal would be for the system to provide in context, also as evidence-based recommendations in the field of cardiovascular medicine. And we're looking into several stages. First, we want to have a RAG agent that can answer questions appropriately. We want to make sure it's answering guideline-based questions that are pretty accurate. And then we want to integrate this RAG agent into a self-improving agent with a apprentice training paradigm that takes experts' feedback and then try and improve the system itself in its responding. And after these two stages, we're going to implement the system or running the system in a clinical implication study. And the main goal is to see, with the system's help, can we really improve the time and the quality on our cardiac patient care? So the data set we have right now, we're using a 200 question data set of cardiology board preparing questions. And these are set to be multiple choice questions with curated answer. And there are also written explanations as well as the scientific paper reference to it. And the next stage, we're going to revise some of the questions, the more clinically relevant questions, into open-ended questions. And then for the system to give us an open-ended response on clinical practice recommendations. For example, we have a patient with chest pain in the midnight. What would you do, and what kind of workup or lab test you want to order as your next step? And then do you want to send this patient out to see a cardiologist? And just an FYI, this question set actually has several multi-model questions. These are medical image interpretation questions that would challenge the model or the system to see if it can really interpret the medical images and use that information for your decision making. Yeah, while most of the questions were knowledge or text-based, these parts, maybe 20 or 30% of the questions are involving medical images. So at the end, I want to mention about highlights in the study timeline. The highlights on the study is that we're trying to really deal with the real world problem. That's to take care of challenges in cardiology care delivery. And then you will be working with experts closely in the field of cardiology. Then there is also a strong clinical potential that we can put this into practice with a relatively short time. And we're looking into hoping at least we'll have one or two CS students that would be willing to work with us. And more is better, definitely. We can look into more different perspectives of the project. And then we want to have a prototype for our step one study, probably in this 2024 quarter. And then by working with us, we're hoping that this is a project that can inspire you to like save lives with us. I'm open to any questions. Thank you.
Other questions? I'll hand over the mic to you.
Hi, thank you for your presentation. I was just wondering, are the responses for the RAG system going to be grounded in any like large medical databases like PubMed, or how are you expecting to ground this information?
So we're hoping to ground that either in PubMed or in the UpToDate. That's another database that we usually use in clinical practice.
Okay, got it. And just one more question is that you mentioned that this could be deployed in like more rural settings, and I was wondering, are there different cardiology practices or considerations that you need to make for different settings if you were to deploy this in more rural hospitals?
We can probably decide that when we're running. So the step one goal is to make sure that it has certain knowledges that are required for addressing cardiology questions. And then I think your question is probably more in the step two, that we have to adjust the model or the system's response according to the practice setting.
Got it. Thank you.
Thank you. It's a really interesting project. Something that occurred to me was the fact that medicine is a practice. Like if you have a patient present with a certain set of symptoms, you could have 2 or 3 or 10 equally qualified cardiologists have different opinions on how to proceed. So I was curious how you were thinking about how to constrain, like how to define what's a good model response, like whether what the model's response is good medicine or bad medicine. How do we approach that?
Well, that's a really sharp question. And we actually just had some exchanges with Professor Lam early in the morning about this. So right now in practice, there are some ways or some things we do that has strong evidence to support. So in our term, we call like random clinical trials. And so those are data with strong evidence. So usually it's like either, oh, okay, you can definitely do that in this kind of condition. And then, so these questions are more like a black or white kind of answer. So we would assume these are easier for the models. And then there are some areas are more kind of gray zone. And then we sometimes call it is the art of medical practice. So yeah, so those are questions or some data with less strong evidence in clinical practice. So in those areas, we could judge the model really based on our expert opinion. And but sometimes in areas that's more vague, sometimes it's actually like case by case approach, and there is no true right or wrong answer. So I think we'll probably try to address to the level of questions with some, but not very strong evidences. So at least we have some references to look into, and then not to those like very individual and questions. Yes.
Cool. Thank you.
Well, thank you, Dr. Zhao. I think that as you can tell from the Q&A, it is really amazing that we get this partnership with Dr. Zhao because we really need an expert in the house. All right, so this is an exciting project, so let us know if you want to be involved in this. All right, thank you.
All right, thank you. Yeah, so feel free to get in touch with us for questions just by email or Slack. Yes, thank you.
Okay.
Thank you. Ilya, does Ilya want to come? Perfect. I have your slides up here, so you can use this.
Are we done with Zoom?
Yes, we're done with Zoom.
Okay.
Perfect.
Hi, everybody. My name is Ilya, and I'm a Stanford Professional Development Program student. I'm creator and CTO of the company behind this product we had. It's a tabletop user interface for talking to agents face to face. Yeah, and I'm proposing the project. Yeah, just a few words behind my kind of agent. I want to propose that like we use self-service kiosks quite a lot. We can order some food in McDonald's, yeah, or to do to print the air ticket. But for kind of if you go to more complicated, more complex user flows like check-in and hotel, it get too complicated to use the touch screen. So we kind of working on more intuitive, hands-free design user interface to ChatGPT or any other LLM-based agents. Yeah, and the case I propose is a receptionist. You have it here in Stanford Research Park with company Inflection AI. This is their office. They don't have people on reception. So instead of the receptionist person, they have the device there. And so the idea of the agent that like normal receptionist role job is to greet people, to be very welcoming, while it should have access to calendar. So the calendar access should be integrated. And then once visitor comes, so it should, either recognize face, either ask name, compare it to the potential meetings in calendar, and then notify the person in the company who has this meeting that the visitor is on the reception. Also, the receptionist job is to take care of delivery people. Some of them don't speak English. Yeah, so it should automatically switch into most time Spanish. So generally, yeah, I can also show how it works, but like for the purpose of the project, the challenges is multi-user conversation, because like in one context there could be different users approaching it. That one challenge. The other challenge is it should notify the right people and not notify wrong people about the meetings. I don't know if it will work. Yeah, just to give you. Oops, I don't know if the sound will work.
Welcome to Inflection. Nice to see you.
Hi, what's your name?
My name is Kim. How can I assist you today?
My name is Brenda. I'm looking for April.
Hi, Brandon. April is the executive assistant to our CEO, Sean White. You can find her by going through the door on the right and down the hallway. Is there anything else I can help you with?
Thank you.
Yeah, so generally this is it. Thank you.
I'm just curious on kind of like the look and feel of the thing. Like, what's the decision behind putting, I guess, like 5 mobile phone size screen there to piece together a face?
So in order to give person feeling that it sees him or her, so kind of it should be, it moves and it pretends to see you. So once you get it as a human size head, it's very easy to, assume that it will talk to you as a human. We can do it pretty much same with tablet on gimbal, right? But it will be like tablet on gimbal. So kind of you don't, so you will see it like a Zoom call rather than of the presence. Kind of 3D object gives you a feeling of presence, like the form.
Is it kind of like four phones pieced together?
Yeah, kind of.
Thank you.
Thank you.
And then next is Suha.
It's a great,
Perfect.
interesting project.
And try your best to stick to 4 minutes. I'll give you a little like.
Hello, everybody. I haven't really fleshed this out, but I had an idea. Thought it was pretty cool. Wanted to present it. So it's AI agents for better content filtering. Basically, I get distracted all the time when I go to like YouTube, Reddit, Twitter. It starts out super like, oh, let me watch some super educational video. And then I end up not watching some super educational video like 30 minutes later. So in some ad blockers, you can like limit the amount of time you spend on YouTube, for instance, or you could tell yourself not to watch YouTube at all. And this can be kind of effective if there's like a decidedly time wasting site, but most sites are like sometimes productive and sometimes time wasting. So an LLM based system could help. It could understand what kind of site that you were on and the content on the site and determine whether that's useful or not. The additional advantages would be, since it's an LLM based system, you could encode your preferences in there. So if you're like a jewelry designer or something, it's probably like productive for you to be watching YouTube videos of, I don't know, jewelry design. But if you're just like some girl who wants to buy jewelry, it's probably not productive. So little things like that you could encode with an LLM system. So here's a workflow I kind of had in mind. This might be like a browser extension similar to your ad blockers. And it could work for you to limit your own like less productive activities, or for you to limit your children's less productive activities. And so if you enter a site, it's determined to be productive or unproductive. And depending on how you set up your system, this could like notify a parent, or you could be like, no, please, for some reason, I really need to watch Twitch for a homework assignment. And yeah, there would be a way for you to negotiate with your LLM agent. Maybe even like upload what kind of rubric your teacher gave you or something like that. So lots of possibilities here. And I would really like this product, which is why I'm pitching it. Oh, I do need a partner, but I joined the class Wednesday night, so like everybody already has a partner. If you don't have a partner, reach out.
I'm sure there's a lot of people who don't. Okay. So does anyone have any questions or feedback?
Well, as a point of feedback, how does it stop me from turning on incognito?
Actually, there's ways to not give yourself incognito already on Macs. Like you can enter some terminal command to do that, which I did because I constantly look for ways to avoid my own like blockers. Yeah.
I'm curious. This type of like problem seems like the person, like let's just say the kid, right? They're going to try to exploit the system and like argue like, oh, I'm using Twitch for homework. So how do you balance like the flexibility of the agent to allow, oh, a site could be useful in some cases, but not others, but also prevent users from exploiting it?
I think that's where the notified parent thing comes along. Like, if you're a kid, you have just a super high tolerance for like, oh, I really want to do this, and I'm gonna like keep trying to exploit the system. So maybe you're willing to spend like hours doing this, and then it'll notify your parent, and then your parent can come discipline you. But for like an adult, there's some sort of like threshold of like, all right, I'm not really gonna spend an hour trying to red team an LLM agent just so I can like get my dopamine hit, I suppose. That's the idea.
Or you can implement it like this.
maybe using cognitive behavioral insights or psychological evidence, try to make the app more human-centered.
Interesting. Okay.
One more question.
This is a suggestion. I think with some of your evaluation, it would be interesting if you built like an LLM red teaming thing. Like there's some papers on using LLMs to generate attacks for other LLMs to jailbreak them, and so you could like simulate the person wanting to watch Mr. Beast or whatever, and see like what creative ways it can try to break your system and see how robust it is.
Nice. Thanks for the feedback. Okay. Thank you, everybody.
Thank you. Next, Rihan, are you here, Rihan?
Okay, hi everyone. My name is Allison John. I'm a senior in computer science on the AI track, and my partner Emily Park is a master's student in computer science. And I'm pitching an idea about using LLMs in robotics, which is a field that I just learned existed last week, so I don't know very much about it, but it seems like a very new and exciting area of research. So one application of LLMs to robotics is called autonomous perception, which is the ability to collect information and decide how to act. So for example, if a robot knows that it needs to clean the dishes, in order to do that, it also needs to know that it should like go to the sink, find the sponge and the soap, and then use those to clean each dish. And so to get those subsequent steps for a task, you could ask an LLM for those steps. And so that can fill in the information. And then it could also be used to do things like if a robot perceives that there are dirty dishes in the sink, the LLM could be used to tell it that, oh, you should go and clean the dishes. Yeah, so that's pretty much my ideas so far. If there are any mentors who have some experience in robotics or anything like this, please let us know. Our emails, our Stanford emails are on the slide. And yeah, that's it. Thanks.
Could I just ask a question? So I'm Mike Stowe, I'm a PlayStation with Mike. We're also working with somebody who does something called virtual home at MIT. So if you search virtual home, they have a simulated environment, actual robots that do things like put together breakfast, and they're working with language models. So maybe I can give you the details if you want after class.
Yeah, that's great. Thank you. Anyone else have questions, feedback, ideas?
I just want to add that we encourage everybody to make proposals like yours. This is wonderful. And we will give you a mentor. Everybody will be assigned a mentor from our wonderful teaching staff. Okay, so we are familiar with the literature. We will help to connect you with other sources as well. So don't worry about that.
Okay, great.
Okay.
Thank you.
Yes.
I have about this project is like for perceiving like a scene or something like that, do you plan on like fine tuning or using your own like image segmentation model, or like how exactly do we plan on or do you plan on taking the multimodal data and feeding it to the agent system?
Yeah, I feel like we would kind of work on like the next step after the computer vision parts, sort of like the inferring and decisions, not the image segmentation type stuff.
I feel like on that note, I've seen people taking a video and chop it out into frames and sending it to a multimodal LLM, a couple of seconds.
Mm-hmm.
So that could be right.
Yeah, that too. Mm-hmm.
Great. Thank you.
Yeah.
So I think with a lot of the multimodal robotic applications I've seen, your AI, how are you keeping in track the state of the environment and how you've interacted with it in the past? Because the robot can very easily look at this frame and tell the objects, but then sort of seeing modeling the environment as sort of a time series. I don't know if large language models are good at that or are a good application of that. I'm also very curious too, because that's just one challenge that I think.
Yeah, definitely something to think about. Thanks.
There is a lot of research in this area. So I think that we can take this offline, and for people interested, we can have discussions on this topic. Thank you.
Michael and Arnav, do you want to present?
We will do the DS5 later.
Oh, okay. Then I guess it's just hardship.
Yeah, it's just like one slide. So all of you have been working with the Genie Worksheets assignment, and here's a new, like an extension to the project that we have been doing with Genie Worksheets. The idea is that you kind of like, so right now what happens, we have multiple calls, or like 2 calls for semantic parsing. When a user utterance comes, we want to map that to the formal representation that we have. So one of the new project pitches that I have is you kind of like generate synthetic data using, let's say, a teacher model. Like we have already learned about like distillation with the wiki chat work. So it's kind of the same, where you generate a lot of synthetic data, and then you try to fine tune the model using this data for having a faster semantic parser. The reason why it could work is that it's a narrow domain. You have a mapping from natural language to a restricted domain-specific language. And the challenges that might occur in this work are basically how do you generalize to multiple APIs? Because for instruction tune, like for the larger LLMs, it's easier to adapt to newer APIs. But here, one of the challenges could be that when a new API comes in, how do you adapt to it, and how do you manage out-of-domain data? And that's the project. So I think this should be an interesting one if you're interested in like fine-tuning models, generating synthetic data, and learning more about it. Okay, thank you.
In this room has seen this, and I don't want somebody to tell me who are in this room is like, oh, I didn't fill in the form because I didn't notice this message. Okay, so what I want to do today is that there are a number of projects that have been pitched, and on Monday I was talking to some of you in my office hours, and it seems like it is a good idea to talk a little bit about how you go about designing and doing your projects, okay? So this is kind of like a mini lecture on this topic. I really want you guys to ask me questions if you have, if you're thinking about the projects or running into difficulties, or you're wondering if your ideas are good or not. Feel free to talk to chime in. I mean, I just want it to be make me want to make this interactive. So, we have been presenting some of the projects that kind of come out of our research, but with this class, we really want to encourage everybody who are interested to propose your own as well. And some students came to me and asked, can I do this? Can I do that? So what I require everybody to do is that when they write their project proposal, you take the problem, you try it on GPT first. If the GPT gives you a good answer already with very little bit of work on designing your prompt, that's not a project for the quarter, okay? But most likely, you come up with a problem where the response looks okay if you give it easy input. If you think harder, make it a little bit harder, it will fail. And that's very likely. And that is fine, okay? As long as you can identify why GPT as is does not work, that is a good project, because we know that there's always this gap. Let's put it this way. If the GPT does not already solve part of the problem, it is really hard to make it work 100%. Okay, so we kind of expected that. It has a good starting point, but the question now is, how do you turn this into something that can be used? So that would make it a good project. Okay, so I've chatted with some people already, and it looks like there are a lot of interesting ideas. So I'm really looking forward to this quarter where we invent this future together. So if you have ideas, talk to us. So the concept here is that today, you hand in the 6-second homework, and in this 1 week, we ask you to formalize the project, and you have to make a proposal by Wednesday next week. Okay, we have office hours, our CAs have office hours, talk to each other, use Ed, discuss ideas, you pitch some ideas, and if you have comments on other people's ideas, go ahead. But we have to finish the definition of your proposals by the end of, in 1 week's time. It is Wednesday. Okay, so when we make a proposal, it is our best guess. It doesn't mean that you cannot change the topic. But of course, the longer you take to decide the topic, the less time you have. So it is always a game that we have to manage. And because every project will have a mentor, you can work with the mentor on making changes to your projects. But as you make changes and so forth, the mentors are aware of it week by week. So we want to make sure that by the time you finish, you have a good project to show, okay? As I mentioned, every project will be mentored. And so the basic idea is that we will connect you. We don't know everything, but we can try to connect you with other groups or tell you what the related work is and so forth. So this proposal is very important because you put it in and then we'll give you feedback on whether that project works, or sometimes we have to sometimes you have to expand the scope, but more than likely, we're going to reduce the scope. Okay, so this is an important part of that process. So I really believe that we can learn from each other's projects. So it is not just you submit and we give you feedback. So we are devoting next 3 classes for people to talk about projects. So the project is the proposal is due next Wednesday. So by Wednesday, everybody is ready to present their projects. But we also offer slots on Monday for people who are, who want to get some feedback before the proposals. Any projects that are presented before Wednesday, need not to be presented again, okay? So you will get to sign up. It's either Monday next week or the next 2 classes when everybody should be prepared. So that is the plan. It's a short proposal. We don't have enough time, but we have a big class, but we really want to see if we can hear from everybody. If you are working with a proposal that's been presented already, you don't have to present this round. Okay, we just have to take it to the final project because we have already heard of the ideas. Okay, so are there any questions about this? All good? All right. So I want to talk a little bit about what kind of projects are available. And I think that there are really 3 themes. Okay, so we talked about the fact that we now have AI and we can accelerate the generation as well as dissemination of information. And I lump it under the concept of the worldwide knowledge concept. And the second set, the next 2 topics have to do with the fact that you try all the things that people have done and it still doesn't work. And I want to introduce you to 2 ideas that we found useful, and we are still working on them. It's not like the the Genie worksheet where we already have a platform for you to build upon, but these are two general concepts, and I want to run over that today because that might be useful for your project. So it's important when you try to scope your project, whether you can handle this in this, the 7 weeks you have. So one is the concept of apprenticeship training, and the other one is the introduction of intermediate representations. Okay, so these are the three things that I want to talk about. So the concept here is that there is a lot of things we can do to accelerate the generation of knowledge and improve access. And we have already talked about the Data Talk project. Just this Tuesday, George Liu, who presented earlier, they just released an agent that can let you talk about FEC data, which is all the election campaign data. And that has now been released to the journalists. And we will see how that goes. So we've talked about that. We also have talked about history chat. Sina has talked about how we are able to deal with old corpora. And I want to show you another project that is under this setting that we have not got into the details. And this is the concept of a multilingual news platform. So we have made a proposal on this. And we actually have a video.
Hello everyone, my name is Tiffany Lu.
Can you
Together
hear?
with Jia Liang, Monica, Tai, and Jennifer, we are proposing a cross-lingual multi-perspective news platform.
Can you hear? There is a... Oh.
Maybe where the volume sign is, right there, like this volume. Or here. Do you mind if I try? I think it's this one.
Oh, you made it go pipe through the...
Yeah, is that okay?
Is it done?
It should work then. Do you want to try?
Hello everyone, my name is Tiffany Lu. Together with Jia Liang, Monica, Tai, and Jennifer, we are proposing the cross-lingual multi-perspective news platform.
We focus on the multiple perspectives in salient global events. In Gaza, Hamas claims they are fighting a war as a resistance to Israeli occupation and blockades, while Israel contends the war is in defense of their people. In Russia's narrative, the Ukrainian war is a fight back at NATO's expansion, while from American side, the war is an unjustified invasion of another country. And there are more perspectives in different languages on the same news, which show how complicated international geopolitical relationships are. That's why it is extremely important to have an analysis and comparison of different perspectives on the same news topic. Today, traditional commercial systems have fostered clickbait. Technology creates generative echo chambers to news consumers. Many countries build state-run censorship, and even crossing firewalls doesn't help readers understand other languages. We motivate our proposal by the question, can we provide a reliable and efficient source of news? Our goal is to create a cross-lingual multi-perspective news platform which translates, compares, and analyzes global breaking news.
To achieve this goal, we propose CLMP, which leverages large language models to break down the language barriers. CLMP enables automatic analysis and comparisons of different languages, all in real time. It first translates the news articles into English, breaks them down claim by claim, and then compares them on a claim level. The outcome will be a summary with claim level similarities and differences between the news articles' perspectives. This has never been done before. It's simply not feasible to build a manual pipeline to achieve the same goal. Here is an illustrative example of what CLMP will be capable of. We can see that even when quoting a statement from the same spokesperson, the coverage by news agencies from different countries in different languages can vary subtly yet significantly. Haaretz, an Israeli news agency, says no significant damage was reported, while Mir, An Iranian news agency says further damage was caused. We have implemented a prototype for CLMP. The prototype takes in 2 news articles on the same news topic in different languages. Here we have 2 articles covering the Biden and Xi's meeting. Our system automatically generates analysis, providing differences and summarize them in a conclusion. Our proposed CLMP will be the first cross-lingual multi-perspective news platform that makes global news more accessible for users and informs them of the multiple perspectives out there. And it will source from 10 different languages. With our platform, the general public can become better informed, news producers can source stories more quickly, and the news outlets can get better exposure. Please consider supporting our initiative, and thank you for your consideration.
All right. So this was a video made to the Brown Institute when they asked for proposals, and the project has been funded. Okay, so this is, we have already prototyped it, but there is still a whole lot of work to do when you have to build it and you can see what's going on, and then you have to improve it. So this is a project, if you're interested, we're very, very happy to get more people involved. Any questions about that? Yeah?
Sorry, they were. I was just going to ask, I mean, it sounds like it's an amazing project and it sounds like a lot of people are working on it already. So if we were to join the project, could you maybe give us an example of something that we might be working on?
Actually, we don't have anybody working on it this moment. And the Sienna actually has done a lot of work on this and building the first prototype, but he is now busy with another project. And so we know enough to carry out the project, but we actually need a lot of manpower from every piece here. Ty and Tiffany, they are journalists from Columbia. And so they are really not helping with the CS part, but they can give you a lot of help with the subject domain. And also Jennifer Pan, she's from the political science, can give us a lot of expertise. Jia Liang is a student. Unfortunately, he has other things that he is doing and moving on. So as you can see, we are looking for help. But we have done enough to know. And also, Sina can give some high-level supervision in the meantime, along with me on this project. Okay? So please let us know if you're interested. I talk to people from the outside. A lot of people outside of the United States is actually very interested in this topic, as you can imagine. It is really a global project. So if there are people here who know other languages as well, that always helps. Okay? Any other questions? Yes, David.
To fight misinformation, is it possible to make it take 7 weeks to partner with a communications agency, perhaps in another country?
We have already built up a lot of infrastructure. So for example, we're using RSS feeds. And this is how we get the news stories. So we have a lot of infrastructure. So you can concentrate on the AI part, in a sense. You can just work with a smaller number of feeds, like a couple of countries to begin with. But the scaling part is either done or we can just do it later. Yes. So we have the basic idea of the of the claim checks, fact checks, and actually we were just discussing new ideas of improving that. It actually is related to the consistency project. The whole basic idea is how are they different? But the one difference in this project is that there is a difference in perspectives. They are not just factual. They take different points of view, right? And then we also want to include that in the summary. There's a lot of opinions involved in that. Okay, so this is it's very interesting because I think there are a lot of people interested in the result. Yes.
It's not like the next Twitter. Can people don't enroll this class also?
Well, maybe we do need a next Twitter now that Twitter is very much controlled by a single by the owner. Yeah. Okay. So love to have people help with this. All right. The more the merrier, actually, because this is really tricky. So.
Hello, everyone.
So what I also want to tell you about is that because of our research work, the Sloan Foundation has reached out to ask us to create a workshop to talk about the opportunities of AI. Okay, you see the concepts, like for example, this multilingual news platform is very, very different from, for example, Wikipedia. Okay, today, if you look at public knowledge, open source public knowledge, Wikipedia is definitely the beacon in a sense of what can be done. Imagine this world without Wikipedia, without Wikidata. Okay, where are we getting trusted information from? So what we are saying here is that Wikipedia, it's encyclopedia style knowledge. There's still plenty to do. News being an obvious example, and there are many more domains, more expert domains. And you really want to create an environment where you have the availability of all the AI tools and the communities, such as the historians, to get together to build up the knowledge and make it publicly available. Obviously, it costs money to make such a platform available. I don't know if you know, for example, that Wikipedia is running at a rate of $100 million a year. Okay, that's what it takes, but we do support it. It is through a combination of sponsorships by philanthropy organizations as well as consumers and individuals. And in other words, and we believe that there is room for a bigger version of an encyclopedia supported by AI. Without the AI, it's too costly. Okay, people thought about, can we put more knowledge together, making all the trusted source of knowledge easily available through linking them to the different sources and so forth. But the point is that it was too expensive. But now with AI, we have a shot at accelerating that process. So this is why we're creating this workshop. It is going to be held in the middle of February next year. And it is an invitation-only workshop because we really want to make it work. We want to get together and talk about how we make it work. It is not just a conference where we listen to a bunch of talks and go away. And we are including not just the CS people, but the funding agencies, the journalists, historians, social scientists, and so forth. And what I would like to see is that work that we are doing in our group, or work being done here in these projects, if it works out, we can showcase that in this workshop. So if we put the multilingual news platform together, we showcase that, okay? And then we show it to the journalists and we say, this is what we can all create between the technologists, between all the different people. This is one of the reasons why a lot of our projects involve the experts. It is not just CS people doing their projects. And frankly, by doing so, we are advancing the CS technology, because we have discovered some really difficult problems, which I will discuss next. Okay? So one of them is the need for apprentice training. So let's take a look at the background. If we look at this kind of a new style of engineering, I call this the LLM-based engineering. LLM gives you the natural language, the knowledge of the world, and so forth. Okay, so given that you have LLM, we can build many things with it. What we have talked about in depth in the last class is how we build a static pipeline, and that is, for example, WikiChat. We found that a static pipeline is not good enough, and so we have been creating other pipelines and using this agentic approach. What agentic approach means is that we're building an agent that observes what is being done and adjusts the actions accordingly. So, for example, this is what we use in the Wikidata semantic parser. The framework is that you start by defining a set of actions, such as, you can look up the properties or you can execute a query. Okay, you define a set of these primitives. The agent, you don't tell the agent what the algorithm is. The agent looks at the primitives and chooses the actions. It performs the action and it looks at its result and it decides what action to take next. So this is working out really well for some of the harder problems for which we cannot just say, do these 7 steps in this static pipeline. And one of the problem here is that sometimes you're at you reach a dead end, you have to backtrack. So right now we just randomly backtrack and we just turn up the temperature and we can try different paths. One of the projects that we proposed in the list of ideas is a tree search of solutions, so you can systematically go through the possibilities, and we believe that this is important. For example, if you want to talk about a gaming coach and so forth, where you cannot just probabilistically traverse the space. Okay, so that's the agentic approach that we have found useful for some of our projects and maybe useful for some of your projects. Okay. So besides that, we also do fine-tuning. So if you have a problem where the instructions just cannot possibly fit in the prompts, one possibility is that you just generate tons of inputs and outputs, to span the space, and then we fine-tune with that. So that's an obvious solution that most people are familiar with. What we use fine-tuning in the WikiChat just to speed our execution up and just to reduce the cost. But in some cases, you may want to use this because you cannot squeeze the information into the instructions. So these are 3 top techniques. I think that you'll be using, some of you will be using these 3 techniques. But what if these techniques are not good enough? This is what we discovered with some of the projects that we are doing lately. So we are now formalizing this concept of apprentice training. The key issue here is that when you look at any jobs that people are doing, that experts are doing, they often have tacit knowledge. They know something about the job. It was never written down anywhere. And there is just no way an LLM can do it because it's just simply not written down. And you really have to distill the information out of the expert's head. So how do we do that? Let me give you a concrete example. We talked about the fact that we create an agent for FEC, the donation to the election. They have to disclose all this information. And we downloaded the information from FEC, and we take the donations, we sum it up, and it turns out that it doesn't match the summary that was reported for the individual candidates. So what do we do? So it turns out that we connected with the expert of the FEC data, Professor Willis, and he explained to us that in the raw data, the donation does not include anything under $200. Okay, so when you add them up, it doesn't match. So this is an example of a caveat on the data set that was in his head. We could not figure out why when we sum it doesn't work. So the point here is that this is just one example. A lot of jobs that we're trying to automate have this problem. So we need to get the information from the experts. And if you are able to take this information from the experts, put it into the system, then everybody can benefit from it. So that's the basic idea. So if you look at what humans do, is that we set up these apprenticeships or internships. You learn, you work, and you make mistakes, and you have a supervisor, your advisor can provide you with with feedback. And the feedback is not through you making mistakes a million times and then observing on your own. You have an expert to actually tell you the reason why you have to do things a certain way. So for example, you have a rule like this. How am I supposed to learn that if you give me a bunch of numbers, when you add up, it doesn't match, and that is because of missing data, okay? I don't even know how to give you a data set that teaches you this observation or this principle. And in other cases, you could give you a data set, but it takes a lot of data. So the point here is that with LLM, I think that we can, it is very important for us to think about a different paradigm. Instead of everything being data-driven, it has to be rationale-driven. If I give you the rationale, LLM understand knowledge in a sense, you should be able to apply it. Because it's really hard to get enough data points for high-level tasks. I want to emphasize why this is different from chain of thoughts. Okay? Chain of thoughts means that every time I give you a problem, you try to figure out the answer. You don't accumulate knowledge from one input to another. What is really important if you want to do these tasks is that you learn from your experience and you keep improving yourself. And so having a self-improvement loop is really important, and this is what we mean by we need an apprentice. We get the advice, high-level advice, we accumulate it, and we make it applicable to new inputs that we see, okay? So let me give you another example. We were doing classification. This is for the ACLID project that we mentioned. So it's a classification of an event across a bunch of possible types of events. But if I have an event, sometimes I can legitimately classify them under different types. So for example, if I have an armed protest, I can classify it as an armed event or a protest event. And when people try to code up this information, they have these rules about what you're supposed to do. And you have to learn these rules. So you can learn this rule by observing many, many examples being coded one way, or you can read what those rules are, or you can ask the expert what are the rules, and you can feed it back into the system. Okay, so if I go the data-driven way, you need lots and lots of data points. So this is why we care about having rationales. The third point here is that humans can generalize rationales. So for example, in this case, having an armed event is a more escalated event, so it is preferred over the protest. And that principle can be applied to resolve priorities between any pair. So this is the kind of principles that you can generalize and apply. So this is the architecture that we think is necessary to solve some of these problems, is that when you take an input, you go through the LLM-based system, you get some output, you observe an error, okay? It is really hard to collect tons and tons of data like this. But when you observe an error, at that point, we can consult with the expert, get the rationale, and capture it and feed it back into the LLM, okay? Rather than try to generate more data or fine-tune the system. You say, look, I'm going to capture it and put it into the LLM. Just to be very concrete, an example here, which is what we did in both of the classification project and the semantic parser project, where we just don't know the caveats in the data. We find an error, we get the expert to tell us what the issue is, and we write them down as rules. These rules can be applied at different stages of my LLM system. One of them is that once I generate a result, you check each of the rule. Each can be a call to the LLM. You check if the rule applies. If so, you revise and you continue. And in some cases, the rule says the numbers may not add up. What we will do is that when we tell the user the answer, we add the caveat. It's like, these may not add up. It is not cut and dry, here is the number. Okay, so this is the kind of thing that we really need to do for the system to actually be usable in real life. You do not want these journalists to report on numbers with caveats that they are not aware of. Okay, that is an absolute no-no. Okay, but we have to turn it into a system. What we are driving at is that I don't want to work so hard for every application. The concept here is that we put this together in a framework and we let other people, or each domain developer capture the feedback in this way, okay? Because we think that this is absolutely necessary because there's a lot of knowledge that is not written down anywhere. So what we think we need to do next is to apply this to many more domains. So if you guys have topics, you want to apply it to finance, to legal, to whatever, keep this in mind because this is one way for you to do error analysis and improvement. You can try it and see how do we provide the feedback back into the LLM. And I hope that by the end of this quarter, we will learn enough to create a general apprentice framework that can be applicable to many more fields. Okay, so this is the second theme. Here's a third thing that we found that is very useful, and that is the concept of intermediate representations. So the problem here is that if you have a complex problem, you have input and you have output. If it is complex, then you need tons and tons of data. So for example, you have a terribly difficult problem of doing robotics work. Okay, you cannot get enough data if you don't try to do something what I'm doing here. Is that you have to break the problem down because it's like driving, auto driving. At the beginning, people say, here is the input. It's like, okay, control the wheels. All right, but this is too big, and you have to. Theoretically, you can potentially generate enough training data for that deep learning system to work. But what I have discovered is that it is important for you to break them down into steps. You have to identify the obstacles. Now you can tune the identification of obstacles. And by the way, when you see the obstacles, and you now know that if you don't see the obstacles, you need to improve that part of the system. Okay, it allows you to focus on a subproblem at a time. So the concept of introducing intermediate representation is just really important. Okay, so I want to show you some examples of it. So we talked about coding. Remember the ACLED example? We are trying to take all the news and we say, okay, where are all the where are the hot regions where you see a lot of violence against women? Okay, you're going to read every single article, or you code each one, and then you can put in a query, find all the records that have such events, and then you say plot their countries. Okay, so this is a concept of qualitative coding. This coding has nothing to do with CS. This is an old word that is used by, in journalism, in data analysis. Okay, so one topic here is that I give you a code book, such as the ACLED events. Can you automatically classify them? So we talked about events, but it can be used for resumes. Okay, we get hundreds of students applying to our grad school and many more hundreds applying to the Stanford School for undergraduate. Can we code it up a little bit so we can do some filtering without reading each article, each resume very, very carefully. Okay, so that whole concept is applicable to resumes, to medical transcripts, and what have you. If you have tons of data, how do we take a first cut? So that's coding. Now, in the example of ACLID, we are already given a code that has been developed over 10 years. Okay, but a lot of times you don't have a code. As a matter of fact, a lot of times individuals have personalized codes. I mean, I look at my PhD applications maybe differently from my colleagues. Okay, so how do we automatically create that code? And we think that one way is that you give to the expert a tool, such as a tool that allows you to ask questions about the documents. And as the expert works on the tool, you help them browse the information once you can locate the excerpts of the paragraphs that I'm looking for example. So as you capture their questions, you can actually infer what the code is. And once you can infer the code, you can use the code and analyze tons of documents ahead of time. So when you ask a question, it is much faster. I can talk about find me all the people who have a degree from Stanford. Okay, it has already been coded. It will be fast. But why is this interesting? You can tell from the questions that experts are asking. Even if this is when you don't have a code, we can automatically extract the code. So that's one of the important intermediate representation for analyzing massive amount of data, aggregating and comparing them. Another example I want to bring up is compliance. There are lots of compliance issues. So for example, you have a transcript, somebody has to decide whether you're going to get your bachelor degree in computer science. But they have requirements. We mentioned that before. So we say this is the AI requirements. A lot of you have seen this. There's a lot of English in this. And then the question is, can I tell from a transcript whether that transcript can satisfy this requirement? It turns out that LLMs are reasonably good for the simple conditions, but can we afford for it to screw up? Okay, it's not as bad if you manage to graduate without and you miss one, but you really don't want to not graduate a student because we screw up the LLM. Okay, so this is just one example. I mean, compliance is just in everything. So in order to reduce the LLM complexity and improve interpretability, you want to introduce these intermediate representation. So here's an example where I can take the requirements, I turn them into, for example, SMT formula, which stands for Satisfiability Modulo Theory formula. Once you put it into the formula, then I can absolutely just run a solver, which is guaranteed to be correct if the constraints are correct. And I can give you the answer. Okay? So with LLM, I may not be able to put it into the constraints perfectly, but the good news is that I only have to do that for each requirement document, not for each transcript. Okay? So I take the document, turn in the formula, and you can inspect it. You can even go fix them and do whatever. And once you approve it, then you can just run this theorem prover and you're guaranteed to be correct. Okay, so you factor the problem into an iffy part, which is hard because you're dealing with English, and then you can have an algorithm to take care of it. So here is an example. You say that you have to satisfy these different requirements. This is a very simple example. Okay, so what we can do is that you take all these statements and turn them into this formula. It's a little code. It is a domain-specific language. It is actually easier, I believe, it is much easier to generate than arbitrary Python code from an English description. Okay, but it's kind of a form of semantic parsing before we talk about queries, and now you're writing SMT formula. But you can easily kind of see the correspondence even if you're not familiar with SMT. You declare the variables, and then you say you have 5 rows here looking for 5 courses that you are taking. So for each one, it's a clause to say that course 1 has to be one of these, course 2, course 3, course 4, course 5. And then the second section here is that these courses have to exist in your transcript. And now it is a fully executable program to give you perfect compliance testing. Okay, so the project here is how do we take English statements and turn them into this formula, and this is easier than trying to prove to just use LLM to say whether a transcript is accurate or is correct or not, is satisfiable, whether it satisfies a degree or not. Yes, you have a question.
Something I'm wondering is that, like, I actually built the same system because I'm too lazy to go in and check all the requirements myself. And the method I used was I had it write Python code to create a set of these 5, and then as it parses my transcript, it will use the Python to check off the set rather than for me. And so this allows the LLM to have a lot less repetition in the code, and I wonder which approach would be better.
The difference is that this is a declarative program. You write down the constraints, and sometimes the constraints are actually circular, and they're much harder than execute the code line by line. This is the tiny example, okay, where you don't need the full, you can easily translate them into Python. But when you have constraints like you can take this and this, but then together they cannot be this and so forth, it actually catches it in, this is called declarative programming, okay, as opposed to you're translating them into executable imperative programs. This is much more powerful because of the theorem prover. A simple example here is that I have constraints. I can take some courses, I can assign. If I have a choice in assignment such that one is correct and one is not, one satisfies and one doesn't, then this will save you a lot of time from your coding, okay? Because sometimes you can decide, I can use this course to satisfy this requirement or that requirement. Which one should you pick depends on what courses you are taking. And this is what it can do. This will solve this without you thinking about it. It will evaluate all the possibilities. It's just a stronger language because you have a theorem prover. Okay? Good question. So this is, I'm just showing you course requirements. It applies to many things. I think in the project proposals, we talk about invoice auditing, and it is exactly the same type of problem. Finally, I want to talk about web agents. There is a lot of it's a popular topic. It's like, how can we get an agent to go on the web and do things for you? And that turns out to be, so there is a data set mined to web, and the authors just wrote a paper that says GPT-4o vision is a general web agent if grounded. But the if grounded is the hard part. What does grounding mean here is that which button are you supposed to push? Because this is very visual. And we actually had a paper in 2021 that shows you the right thing to do is to introduce an intermediate representation. And the representation is a description of the visual elements in words. So for example, you say, enter the user's email in the text field under email address or username. Humans can understand that, no problem, okay? But now you have to push the right button on the screen, okay? Now that is the grounding part. So what we have done is to show that you take expert sentences like this, you break them down into a combination of a few actions, such as go to, ask, and retrieve. And when the retrieve, the description is that it's an email address or username, and then and so forth. So you break them down into these description. Now you have to find the thing on the web. So then we actually use a machine learning module to match the description to the actual HTML operation. Once you break it down, then you can just do machine learning on identifying visual elements rather than from the very top to the very end, which is what the Mind to Web project is. Yes?
CoStorm right now, is there like a multimodal setting? Like if I want to, like.
Please add one.
Okay.
We have not done multimodal on Storm. This is obviously a multimodal project, and this was done before LLM. This is 2021. This is time to revisit that concept of intermediate representation. We have 2 questions. Yeah, go ahead.
I thought it was interesting, sort of seeing a connection between this web agent and the theorem proving side, which is that there's already some automated tools like the lean programming language or like theorem proving programming languages, and likewise there's like a bunch of architecture for testing websites, like Selenium is something that comes to mind. So I'm curious, like
you can use all these tools, but
right.
The problem here is how do I say it in natural language? That's the leap that we are taking. So Theorem Prover is a project that has gone on for a couple of decades, and we have amazing theorem provers. Use it. I can tell you that there is no way you can expect an LLM to be as good as a theorem prover because it is an NP-complete problem that it is actually solving. You have a question?
Actually, similar test cases because we know the older system are building on the machine base, not human base, and if we use with visual, I think could be one direction. But is there any possible that change the machine system to make it understand the AI part?
If I don't have to deal with the web, I'll do it in the Genie worksheet way. I just bypass the visual. I know that I need this information. I just ask and I put it in. I don't need the web, but there is a lot of legacy problems. That's why we want the web. It's all a legacy problem, I think. Unfortunately, that's true, that you have them. Okay, so this is it. So one last question.
Yeah, I sort of had a follow-up. What I was getting at is that, like, if there's tools to sort of programmatically do some of these things already, and I know that, like, LLMs can be really, really good at generating code.
They are not very good at generating code. They are generating code. The problem here is that there is easy code and then there's hard code. If you wanted to generate a website, it's very reasonable because you can tell when a website fails. If you wanted to generate security code, I would say no. Okay, so this is what I mean. So I have a student who loves this, and he has been using those co-pilots and stuff like that for writing code. And finally, after a little bit of that, he came to me and he said, the bugs that the GPT introduces are really hard to find. Okay? Just keep that in mind. In software engineering, we all know that the time you write the first code is a tiny fraction to the lifetime maintenance of the software. It's debugging that is hard. So I always say, find the best programmer that do not introduce bugs. I don't mind if they even tick slower, but you often are not. They do not introduce the bugs, and you will have an easier time. I love using GPT to help me remember which APIs to call and stuff like that. It is a really good development environment. But if you want to write something really hard and you care about the correctness, be careful. Okay? Just be really careful. All right. Okay, so that wraps it up today, and then we will pick it up again on Monday. And please sign up if you can on Monday, because we want to give you early feedback. All right?